Okay, let's look at this question. They said for this question, they said what? They said that for what value of the a does limit x approach to a x over 2. This one, be careful here. This 2 brackets means greatest integer function, okay, exists. So you go like this. Find out what the value of a make this one does not exist first. Okay, first let's quickly review what's the meaning of the greatest integer function. Okay, the greatest integer function is this. For example, if you have 2, that's the time greatest function equals what? 2. Because they said this means we need to find the greatest integer possible here, like this one. The greatest integer possible, this is 2 here, right? The greatest integer possible less than 2 or equals to, of course, 2 is the integer, so that's why you gotta pick up 2. But if you have this number, like for example, 2.5, like this. So 2.5 is here. So the greatest integer possible less than or equals 2.5, but it cannot equal 2.5 because 2.5 is an integer. It's not an integer, right? But this function looking for the integer. So the greatest integer possible will be still 2, okay? Now, a little bit challenges this one. For example, like a negative 1.5. And here is negative 1. If they say find the greatest integer function when the x equals what? Negative 1.5 means you're looking for integer greater, less than or equals to negative 1.5, as big as possible. So as big as possible, still bigger than, cannot be negative 1.5 because negative 1.5 is not an integer. So the maximum, the least one, the greatest one, but still less than negative 1.5 will be what? Negative 2 here. So the answer must be negative 2, okay? This is just a quick review about what's the meaning of greatest integer function. So, and if you really graph this one, you will see that, let me just clear this part first, okay? When you graph this one, you will see that there is like a gap at a certain point. For example, like x, for example, I put like this, like still 1, okay? Now, if you put a limit, if you put like this is the, or put this as the x, and you have a limit x approach to 1. When you have this, what happens? Huh? So let's check what happens with this one, okay? So this is the x here, right? When x approaches 1, if you want to find this limit, you need to find what? You need to find the limit x approach to 1 from left side of this x, right? And also you need to find what? Limits x approach to 1 from the right side of this one. You got it? Okay, let's see what happens for this graph, okay? I put the graph somewhere here, right? When you see this question here, this is a 1 here. This is a 1, huh? If you go from the left side approach to 1, the x, so that means the value of the x will be like a 0.9, 0.99, like this kind of numbers, right? So if you find out greatest integer of this will be what? 0, because this is decimal numbers, not the integer. The greatest integer possible will be 0 because that's on here, right? Okay, so that's why this one will be equal to 0. Okay, now let's look at this in limits. This limit shows that from the right side approach is 1. So you got to go this way, approach to 1. So when you go this way, approach the 1, what happens? The number will be like a 1.01, 1.001, like this kind of numbers go approach from the right side approach to 1, right? Okay, if you do this one, if you do integer, greatest integer function, the greatest integer possible, but still less than 1.01, right? That will be what? That one will be 1. So this one equals 1. What happens? What happens here? The graph will be like this. Will be like this side will be 0. The function, the greatest integer function is 0. But when you go to here, this is 1. You go to 1 like this. This is not included. Okay, so you can see that when x approach to the integer here, like this function here, any integer, 1, 2, 3, 0, -1, whatever, as long as you meet this integer there, they have the gap. So left limit not equals to right limit. So the limit does not exist. So from here we can see that a, see here, but here is what? X over 2. So that means what? A must be what? An even number. If A is an even number, for example, A is 4. 4 divided by 2 is 2. And as long as this part is integer, the limits will not exist. So we know that as long as the limits here, inside here is an integer, it will not be, the limits will not exist. That means the x, because this is x over 2, so that's why this a must be even number, because even number divided by 2 will get what? Integer, right? Because even, for example, 6 divided by 2, that will be 3, right? That's integer. As long as this whole thing here is integer, the limits of this greatest integer function is not exist. So we've noticed that a equals in even number, the limits x approach to a, this one is not defined, not exist. So if this one, but here they ask you what values of a does this one exist? Because here is not exist, but exist should be what? A can be what? Any numbers except a equals to even integer here. Okay, so let's recall what we did for this kind of question, because they said we need to find out the limits when x approach to a, this greatest integer exists. Instead of finding all the values exist, there's many numbers there. So we find out which a value make this one not exist first. So to make this one not exist, you're gonna have what? A is any numbers, because when you have this part is integer, as even this is integer, we showed that this one is not exist, the limits does not exist. So to make x over 2 is integer, right? Integer means what? 0, 1, 2, 3 up, and then -1, -2 down, right? No decimals, no fractions. So to make this one is integer, the x must be what? Even. Like a 2, 4, 6, 8 divided by 2, still the whole number, integer, right? Or negative number, integer, right? So we find out a can be any real numbers, okay? Any real numbers except a is what? Even integer. Okay? So that's the one value of a possible to make this function limits exists. All right? So if you have any questions, please let me know. Thank you. Bye-bye.